done over the weekend, then I realize that there's some more that we need to go over, then I'll do some more since quite a few is not finished. Okay, so using the t-test on the calculator, find the p-value. So we've got our sample mean, our sample standard deviation, sample size. What was the p-value? So 0.0232. Okay. Again, make sure that you do the correct alternative hypothesis. What was supposed to be our alternative hypothesis here? Okay, why was it going to be not equal to? We just assume it's always not equal to? No. What was the original hypothesis? Like, what was the original experiment? That it is just what? Yeah, but why was it not equal to? What was the wording of the question that tells us to not? It just says different than, right? Does it give us an indication of whether it's going to be greater or less than? No. Before the experiment, did we have an inkling that it might be greater than or less than? No, so we just did not equal to. And so you had to do a not equal to, and so y'all did not equal to a two-tailed test? Okay. So would we reject at alpha equals 0.1? Yes, we would definitely reject at alpha equals 0.1. Why? Because we have.
It's higher than alpha.
You mean it's less than alpha?
Mr. King, you know I'm not good with these things. You know I'm not good.
We gotta fix that before that AP exam. You gotta know less than and greater than.
I don't know alligator farm.
But
The
look,
alligator
what's forget the alligator.
Hey.
Yeah. Which side of this is bigger, the left side or the right side? Okay, so the right side's bigger? Okay, so this would be my bigger number. And so this is the smaller side? So this is the smaller number. So this is less than this.
Okay, and then you read left to right.
Yes.
Da-da-da is less than, okay.
Yeah. This side, you see how it's bigger?
Uh-huh.
Without any numbers there, it's still bigger, so it's bigger than or
Greater
than this. Yes. Okay.
Hold on.
All right.
Wait, what is that CON? What is that?
Well, I wasn't done. When do we reject it?
Oh.
This is giving us convincing evidence for
The alternative.
alternate hypothesis, right? We want to work that out more, but why do we reject? We have convincing evidence for the alternative. Okay? At alpha equals 0.05. We also reject, right? P-value is still less than alpha. We still have convincing evidence for alternative. What about at 0.01? We fail to reject the null, not convincing evidence for alternative. One thing I want to make a note of really quickly, because I just thought about this, we always are using the phrasing convincing evidence. Does anyone remember, you might have seen it on progress check questions, another way to say convincing evidence? Statistically significant evidence. Convincing evidence or statistically significant evidence. You've probably seen that. All right, did y'all do your T intervals already?
Yeah.
Okay, what's the 95%? So 97.3 to what, 98.5?
Yeah.
Okay. So would that cause us to reject our null hypothesis of, what was it, 98.6? Are you sure that's 95%?
Well, it's 98.
On the other right about the full number is 98.497.
For this one?
Yeah, it's like 98.4.
On that one for 95.
Oh, yes, sorry, I was reading that. We had convincing evidence for the alternative, yes. So we would reject the null hypothesis, right? Why is there convincing evidence that mu does not equal 98.6? So it's not captured by the interval, so that value is not plausible, right? So that's what I was trying to get to see there. So not plausible. Does anyone have 90 or 99% yet?
Yes. 99 is 97.0948.
97.1
97.1, yeah,
to,
98.7.
so would we reject our null this time?
No.
No, because mu equaling 98.6 is plausible, right? That is a plausible value. Do not forget, all an interval is telling us is plausible values for the parameter. Not for a population set of measurements, not for a statistic, not for a sample number of measurements. It is a plausible parameter. All right. So, please note, if there is convincing evidence for the alternative, the null is not plausible, right? If there's not convincing evidence for the alternative, that original value is plausible. Okay? What's your question? So if you look like you have a question. Huh?
I don't think I did something right.
What? Which part?
No, we haven't gone
Which one? Oh, the 90%? What'd you get?
97.4 and 98.4.
To 98.4? Yeah.
So you don't reject
No, we would reject.
it?
Because
Oh, wait,
remember-
98.6.
Yeah, the null was that mu was equal to 98.6. Is 98.6 plausible? No, so you would reject your null. So yes, yeah, so we would still reject our null in that case. Okay, questions, comments,
Freaky.
concerns before we continue?
No.
What's you got, Andrew?
So you don't even have to have your p-values and your alpha or.
So, one thing I will point out is a confidence interval approach really only perfectly corresponds to a two-tailed test, because there's my two tails, and think about the idea as the confidence interval being inside of here.
So only when it's not equal to.
So only really when it's not equal to, yeah. So a confidence interval can give us more information. The reason why we focus so much on p-values though, is like when we do chi-squared next, or tomorrow, not next week, no, next week, not tomorrow. When we do chi-squared, you cannot do a confidence interval, right? So there's a lot of procedures out there where you have to do a hypothesis test, so we need to know how to do both. But a confidence interval typically gives us more information. And a confidence interval only perfectly corresponds again to a not equals to. Okay, questions?
No, I
Okay,
have a question about the homework.
okay, perfect. What you got?
No, this is not a referral question.
Huh?
No, I don't.
Oh. Okay, I got a couple progress check questions that I wanna go over. And then we will pick back up with this, cholesterol reduction thing.
Freaky fast stuff.
Okay, so I found out that I could have made a PDF of all these progress checks so far and put them up like this, which is gonna make things way easier.
Something was wrong with my body.
So let's look at, I've only picked two that we're gonna do first with, so this is progress check B. B and C, yeah. Yep. So I got two from progress check B, and then there's actually one we're gonna come back to later after reducing cholesterol, and then 2 or 3 from progress check C. But here's progress check B. An agency that hires out clerical workers claims its workers can type on average at least 60 words per minute. To test the claim, a random sample of 50 workers from the agency were given a typing test, and the average typing speed was 58.8 words per minute. One sample t-test was conducted to investigate whether there's evidence that the mean typing speed of workers from the agency is less than 60 words per minute. So, before we get into the interpretation, I want to talk about a couple of things. So like, just big idea, what's the null hypothesis? Like when I read hypothesis test, I think null right away. What's the null hypothesis? It equals 60. Now technically they say 60 or more, but what we want to look at is the alternative that mu is what? Is actually less than 60. Notice we should know less than because our value is what? 58.8. It is less than, right? And so like what we are doing is we doubt their claim, right? And so do we have some evidence that the true mean is less than 60? Yes. But what are the two explanations for why that could have been less than 60? one of the options is sampling variability. Is there just, when I look at a distribution that is centered at 60, is there a chance that I get something less than by chance alone? Yeah, randomness, right? Like, there's a chance that I get something below. But if there's convincing evidence, it's so unlikely to get by chance alone that I don't think it was chance alone. Okay? So those are things we want to keep in mind. Like, there's a chance this is true, and I got this value just due to sampling variability. So like, based on this p-value, does that p-value tell us, man, that 60 is probably wrong, or does that p-value tell us, sampling variability could have been at play? Sampling variability could have been at play. That's not that unlikely. Remember, it's when it's so unlikely by chance alone that I reject the null. Alright, all that to say though,
Oh my god.
what answers distracted us?
Kind of all of them.
All of them? Are there any of these that we can eliminate right away? Say again? What's wrong with A, B, and C?
Probability.
I thought
It starts with the probability.
It starts with probability, that could be okay. I will say this, I would have gone down to D and E right away.
Are those both wrong?
Huh?
Are those both?
No, I would have gone down to, or gotten to D and E right away. Because remember, what is the whole point of a p-value? We are assuming something.
that extreme more
That's later.
means.
We assume that the null is true. So if what? So which one says if the null is true? D. Yeah, like D is actually the only one that says the null is true. If the mean typing speed is 60 words per minute, that's what we're assuming. We're assuming this to be true. If that's true, what's the probability of a sample of 50 workers having that mean or less? That or more extreme, which I think that's what you were talking about, right? That or more extreme, which is important, but that's not what we're assuming. We're assuming that the true mean was 60. And it's not that the probability is this, that the mean typing speed is 60 words per minute or more or less. Like, it's assuming that that's true. What's the probability of getting our statistic or more extreme? That's what a p-value is, assuming that the null hypothesis was true. What's the likelihood of getting that or more extreme? Which, don't let me forget, I'm actually going to pull up a question from the test that I want to talk about in a second. Okay. Number 10. Milk has a pH of 6.7, slightly acidic. Cheesemakers add a culture to milk to lower the pH, making it more acidic, and that's what turns it into cheese. Manufacturer is experimenting with new culture that claims to produce a pH of 5.2, which is perfect for cheddar cheese. A set of 50 test batches results in an average pH of 5.11. One sample t-test was conducted to investigate whether there is evidence that the mean pH is different from 5.2. The test resulted in a p-value of 0.018. Okay, so bring in some other information. What type of alternative would I have here?
Not equal to.
Not equal to. It says just different, right? A not equal to, which I'm willing to bet is going to play into this and what some of us got, because here's the thing. When I say a not equal to, what's going to be the center of this distribution?
Oh,
So not equal to what?
5.
5.2. So my null was that it is equal to 5.2, so what's my center? 5.2. But what was our statistic? The 5.11, right? So I haven't converted it to a z-score yet, or a t-score. I'm not talking about the p-value, I'm not talking about the probability. But notice, we said it not equal to, right? So is that a one-tail or a two-tail? So it's not just 5.11 or less, it's also 5.29 or greater or more. Like, we need to recognize, hey, it's a two-tailed test. So when we talk about this p-value and interpreting the p-value, when it's a not equal to, we gotta look at both sides. So notice if it was 5.11 or more, that would definitely not be 0.018. Ooh, so they actually flipped it a little bit here. Okay, which answers can we quickly eliminate? A and B, right? What do A and B not refer to at all? the null, right? They don't say anything about the true mean being 5.2. C, D, and E do. Anybody know what the correct answer is now?
E.
Why is it E and not C?
Huh? It's the only one that mentions like two-tail.
It's the only one that mentions a two-tail. We gotta recognize that not equal to gives me a two-tail test. So it's not just 5.11 or less. It's also the other side, which we didn't get, but because we didn't know from the beginning, we didn't say that it was gonna be less than, we just said it's gonna be different. So it's 5.11 or less, or 5.29 or more. Does that
Wait, so
help it make sense? Yeah.
Not equal to is usually a two-tailed test?
No, not equal to is always a two-tail test. If it was just less than, it would only be this one tail. If it was only greater than, it would only be this one tail. If it's a not equal to, that p-value is both tails. In this case, by the way, would I reject or fail to reject the null? I would reject. We need to recognize that p-value of 0.018, or at least if it was a 0.05, right, or a 0.01, we would fail to reject. But if that p-value is really low, you have convincing evidence for the alternative, okay? So there's 9 and 10, I picked 12, 15, 17. Okay, so 12 here. 2 community service groups, J and K, each have less than 100 members. Members of both groups volunteer each month to participate in a community-wide recycling day. A study was conducted to investigate whether the mean number of days per year of participation was different for the 2 groups. A random sample, okay, so I do want to pause and point out, as soon as I have read this, do you know what I'm thinking about? See, this is what we want to get to. We're conducting a study to investigate whether the mean number of days per year of participation was different for the 2 groups. Okay, maybe matched pairs, but definitely well, it's going to be 2 sample or matched pairs, but it's going to be what? Is it going to be a test or interval? A test. Is it going to be a t-test or a z-test? Why do we know t-test? So it's a mean, right? We don't have a population standard deviation, and we're investigating whether there is a difference. Does it say plausible values? No, just if there's a difference, t-test. Now, here's the thing. Right away, as soon as I read this, I know it can't be matched pairs. Because what did we have to do here in our matched pairs? And we're going to come back to this later. Didn't we have to literally pair each individual up? If you have different sample sizes, can you pair individuals up? No. Okay, so it's not going to be matched pairs. It can't be a matched pair, so it's a 2-sample t-test. Yep. For a difference in population means. Again, we're going to wrap up this in a second. All right. Which of the following conditions for inference have been met? What are the data collected using a random method? Yes, no? Yes. It literally says random sample. Okay. Is each sample less than 10% of the population size? No. Each group has less than 100 members. So, would I even do an inference procedure here? Nope. Okay. Is each sample large enough to assume normality of the sampling distribution of the difference in sample means? Yes. Why? It's over 30, so it's satisfying the central limit theorem. Don't forget that central limit theorem is at play. So the correct answer is D, 1 and 3. So I'm not sure what the most common incorrect answer here was, but we do want to recognize we got random, we got central limit theorem. But those samples are way too big in respect to the population size. All right, 15. A random sample of monarch butterflies and a random sample of swallowtail butterflies were selected. Difference in the average flying speed was calculated. Okay. 2-sample t-test for the difference in means was conducted to investigate whether the speed at which, I'm going to start randomly assigning groups just so y'all are not together, whether the speed at which monarchs fly on average is faster than the speed at which swallowtails fly. All conditions for inference were met, and the p-value was given as 0.072. Hey guys, notice this is a common one we keep missing. Interpretation of the p-value. which answers can we quickly eliminate?
A and B.
Okay, we gotta assume what?
The null,
The null, which is they are the
the same.
same, right? So mu of monarch and swallowtail, so we're assuming that that difference is,
The same.
so it's 0, the difference is 0, okay? What's gonna be our alternative though?
Doesn't, yeah.
Look at the wording of the question again.
One's like faster. The monarch.
The monarch is faster, so is that just not a not equal to?
That's greater.
So if this is bigger than this, it's gonna be greater than 0. Notice that's important to recognize, is it less than, a greater than, or a not equal to when interpreting, because which, actually they don't even give really one that is a not equal to. But what's the correct answer?
C.
To or greater than the sample difference. C?
Yes.
What's the difference between C and D?
D is
null.
Ah.
faster.
Assuming they fly faster. Yeah, we didn't even have to know all that. We just need to recognize we have to assume the null is true. Okay? So here's what I want y'all to hear me on this really quickly, because this is where you gotta be careful. I said this before, and this is super true when we get into all this stuff. When it comes to AP multiple choice, you've gotta dive into the details and you gotta think about those big concepts. Because if we just remember interpreting a p-value, we have to assume the null is true. There's only one answer choice that even says that. Okay? And so like that would have gotten this one. Earlier ones, okay, assuming the null is true, do I have now a one tail or a two tail test? And so you have to account for that. So you have to understand the key language of statistics. All right, number 17. All right, so I'm not even stressing all these things. I'm just going to look at this question right here. Based on the p-value of that, which of the following statements is correct? So p-value of 0.027, alpha is 0.05. What should we do? Don't look at the answer choices. We should what? Reject the null hypothesis. Okay, so which answers can we eliminate? Heck yeah, C, D, and E are out because P is less than alpha. Sweet. Notice, without even knowing reject or fail to reject, as long as we know our inequality symbols, Kenzie, we know that D and D are wrong, right? Because that says P is greater than alpha. Okay, so what is the correct answer from here? We can't miss this.
B.
B. Why do we reject? Because the difference is,
Greater, less than.
well, no, this part, statistically significant. There's convincing evidence. It's statistically significant when there's convincing evidence. When there's not convincing evidence, not statistically significant, that's when you fail to reject the null. We gotta know, reject the null, convincing evidence for the alternative. Fail to reject the null, not enough evidence for the alternative. Okay. What questions, lingering questions do you have so far? I did not get any lingering questions about the DYU. Were we able to figure out what was wrong with our DYU answers? Okay. Okay. What?
Nothing, I didn't say anything.
You didn't get to that part?
No, I didn't.
What? Okay. I can't help if you don't ask. Okay.
You don't like you.
Yeah, I could.
That is true. A lot of y'all did do very well. Okay, really quick though, I want to talk about this question on the test that y'all took before Thanksgiving break, right here. Okay? I know that this is a really, really weird question, but I need y'all to recognize that this is a simulation. The reason I bring this up is, when I was talking with someone about this question, I don't remember who it was exactly, they're like, it's basically a p-value. And it is. Literally right here, it says, of Audrey selling at least 7 of the 30 selected tickets, is it unlikely to have occurred by chance alone? That's the question of a p-value. When you can't do a traditional hypothesis test, you have to use a simulation method. Can anyone tell me why, looking at that simulation, you can't actually do a hypothesis test? No, we have a hypothesis. Notice she sold 7 of the 30 tickets, so the null is that she sold 7 out of 30. Okay, the alternative is that she is selling more than 7 out of 30, right? No, she sold 7 out of 30. The null is, 30 out of 600. Because in all reality, that's how many she should have sold. For some reason, she got more than 30 out of 600. But no, look at that graph. There's something about that graph that prevents me from doing. It's skewed to the right. We need to recognize that's a skewed distribution. I would not be able to do a hypothesis test in this case. Okay, but the idea of a p-value still holds, right? At or more extreme, right? If you added it up, it was 138 out of 1,000 trials. So how likely is it that she sold at least 7 of the 30? The likelihood is 13.8%. Is that super unlikely? It's unlikely. It's about 13% of the time, 14% of the time, but is it super unlikely? No. Is it so unlikely we would say that someone cheated? No. It's not less than 0.05, right? They even told us significance level of 0.05. It's a simulation. It's a proportion or p-value, probability of that or more extreme. Questions about the simulation?
No.
Good. Okay. All right, let's do a quick recap. If you, by the way, if you come up with a DYU question, please let me know. Listen, I need to know what questions you have in order to be able to answer them. Hopefully, you were able to figure things out. Growth and learning, that's what it's all about. All right, let's recap cholesterol. We're going to do some final quick notes based on this cholesterol activity. I do want to note it or point out, I should have actually highlighted it. We are finishing up everything with this one cholesterol activity. So match pairs design and standard error and sample means. And so this one lesson, and we'll do quick notes on multiple lessons, but this one lesson allowed us to talk about significance tests for a difference in means and for a mean difference. We're going to finalize and formalize that difference today. So I haven't finished it yet, Sophie, but we're going to talk about it today. So recap cholesterol. So please remember, we did our cholesterol experiment. Do y'all have the data on your calculator still? No. Huh? Okay. How about this? Log on to a calculator and I'll send this data out. Okay? Yeah, it does need a hat. If it doesn't have a hat, get one. First letter of your first name and your last name. Yeah, Kate, you're dead. Whatever you made it.
Am I logged in?
I don't see anyone logged in yet. Oh wait, do I even have y'all?
Oh, you don't have it on.
Yeah, that helps.
What if I hear I know it's, I'm pretty sure it's stats,
Okay, alright. It should be allowing you to log in, or yeah, log on in just a second, sign in in just a second. Just giving you a little round symbol so you can log in.
No.
Still no?
To select the network and I'll
Why do you have power but no Wi-Fi? There we go.
symbol.
Yeah, the Wi-Fi symbol, weirdly enough, is when you don't have access. Alright, it should be giving you that circular symbol in the top right soon. Showing me that it's sending out a signal. Is it showing you that symbol yet? Second, I'm just gonna have y'all type this data in. Okay. It's like 14 data points, you'll be right. Why are you not? Alright, just type these data points in. So create a new page. Type in your current, your new. Let me know when you get those 5 sets of data points in.
Why? Oh. Wait, Sophie.
Wait, why was it so hard? Why would you so hard?
I get it. Well, mine disappeared as soon as I put it in. No, this is just too slow. You go back to.
You have your current and your new. I was like, you might have your data in there already. Everyone have at least those sets of 5, that the first 2 data points, current and new.
No. Sophie, wait.
60, 79, 54, 60. 79. What was it? 60, 79, 54, and 60? No.
I got it wrong. Wait, what was the?
Oh, I was right. 54 and 60. Okay. So there's all 14 data points.
What's the emotion?
Hmm.
Just a key test.
Okay. So,
What'd you do?
say again.
What's the,
Okay.
yeah, the new?
What do you mean?
Oh, what's the new?
Did you do a one? You did a t-test, but how many samples do we have?
2.
We have 2 samples, don't we?
Sure, yeah.
Awesome. Here you go,
Oh,
Sophie.
thank you.
So guys, please note, we do have 2 samples here, so if you're gonna do a test, you gotta do a 2-sample t-test. Mm-hmm. Good. Okay, so do your 2-sample t-test.
Oh my God.
In the new or is it new in the current?
I believe I did current minus new. No, I did new minus current. Yeah, we did new minus current.
What are you on?
I can't do statistics.
Is it not even?
You're still clicked inside of a box then.
Is it new? Is it not even new?
I think we wanted, what we said is we wanted the cholesterol, the new medication to be better, didn't we? So we didn't just want them to be, not be equal to, we said new minus current is greater than 0, because we wanted more, we wanted a reduction, a higher reduction.
It was new minus current.
It was new minus current, yeah.
2 sample t-tests? So,
Okay, so guys, I'll go back through this up here if you're still a little lost.
is this
My text just.
So menu, statistics, stat test, and do a 2-sample t-test. Please notice we have 2 samples, so we need a 2-sample t-test. We have raw data, so we can put data in there. What's up, Talib? Say again. Okay. As soon as I put this in, I'll be over there. So look, you do new minus current. Could you flip it? Sure. You just have to make sure you do your hypotheses the opposite direction. It has to be greater than. So that is the p-value you should have gotten. Yeah, so here's why. It's because you're still clicked inside that box. You have to get out of the box first. Okay? So you should have that t, you should have that p-value. You should also have already had this written out on a sheet of paper, right, from when we went through this problem.
Alternative high.
So remember, we wanted the current to be better, so mu1 is greater than mu2. Okay?
I pulled it.
You what? Oh, you pulled the data? Don't do it, I'll bite you. Alright. So, remember, we do have a pretty low p-value this way, but what did we set our alpha to? Right, remember we thought a type 1 error would be a really bad thing, so we set a low alpha. So with this low of an alpha, would we reject or fail to reject the null?
We would fail.
So,
We would fail to reject. Our p-value is greater than the alpha. So is it unlikely? That's a 1.5% chance, 1.6% chance, but it's not so unlikely we would reject the original assumption that there's no difference. Please notice that a calculator again is spitting out my degrees of freedom. It's spitting out the sample means for you to report those, the standard deviations, all of that fun stuff. Now, what about if I wanted to do a confidence interval? What would change? And that's what I want to just quickly talk about as we go through. What would change if I were to do a confidence interval? In my choose, what would I need to say? So a 2-sample t interval for a true difference in means. Okay? I would need to define that mu1 minus mu2 or mu(n) minus mu(c). In the check, what would change in the check? I would say normal would be the same,
Normal and then random.
and then random would be the same. Did we have a random sample? Ooh, be careful. I said it wrong originally. We didn't have a random sample, we had random assignment. Remember, it was an experiment. So we don't need 10%, we just need random assignment. You don't need independent random samples either, it's just random assignment. Did we have a large enough sample for the central limit theorem? No. So what did we have to do? We had to look at our graph, right? When I look at this, are there any outliers? No skewness? No. So can we do the test? Yes, we can run it there. All right, we'll come back, we'll look at log and then confidence interval. We'll look at that quickly, wrap up the unit when you get back in about 15, 20 minutes. Do some AP free response questions after that. The unit 6, inferences with proportions. You have to define your parameters, checking your conditions. Remember, the only thing you have to check differently is, this is an experiment, so we had random assignment, but everything else still the same. How would I do my confidence interval here?
Correctly. T interval.
Okay, so it would be a 2-sample t interval, I agree, but come on, when I actually get to the calculate portion, what else do I need? Get out your formula shades.
You need
So start at the beginning. What do I need?
X bar 1. Oh.
So I need a statistic,
Minus a parameter.
that plus or minus
Oh, critical value.
critical value
Standard
times standard error. Remember, by the way, what is critical value times standard error give me?
margin of error.
That's my margin of error, okay? Now,
There's no combination.
again, reading through this star as we're focused, am I going to look here at proportions or am I going to look here at means?
Means.
Means, okay, so I'm looking at means. Now I'm filling everything in. What is my statistic?
X bar.
X bar
1.
or I guess new in this case, minus X bar
Of
C,
current.
current, plus or minus,
T star.
okay, so T star times,
I don't know. Yeah.
I would say, we got to move it to here, so it's the square root. Do we have sigma?
No.
Do we have population standard deviation? No, but we did get a sample standard deviation, right? So S1 squared divided by, ooh, that should be N plus current Okay, so now all I have to do is I have to fill this stuff in.
Yes.
So don't forget that. All I gotta do at this point is fill in and even use the calculator. Now, I might just go ahead and run it in the calculator. So we should have our data in. What am I gonna press to run this confidence interval? Menu.
Stat. 4.
Confidence
intervals? 3.
I was like, we're doing a confidence interval now, right?
Yes. 4.
So is it 2 or is it 4?
4.
It's gonna be 4. Remember, we do have 2 samples. Pay attention to your details. We do have raw data, so go ahead and put that raw data in. What's my first list? New. Second list? Current. What confidence level do we want?
9.
I'll remind you, what significance level did we use?
0.01.
0.01. So what confidence level would that go with? 99%. Technically 99.5% because this is a one-tailed test, right? Actually, so 90. It was a one-tailed test that we did, wasn't it? So it wouldn't be a confidence level of 99. It'd be a confidence level of 98 because it'd be 1 on each tail. So that's how you can convert a one-tailed test to a confidence interval. Okay. Alright, notice there's all my fun stuff. Alright, so I will say this, with them giving you this margin of error, if you wanted to, I bet the AP exam would be okay if you just put margin of error in the place of t star times the square root of all that stuff. But don't quote me on that, so I would just go ahead and write all that out. But pull all our stuff. What is, so x bar 1 minus x bar 2, so 56.857 minus 31.857 plus or minus. Now remember, they don't give us our t, so we're going to have to come back to that. 18.25 squared divided by 7 plus 20.383 squared all divided by 7. So I'm just pulling all that in. So I need to find that t star. How am I going to find this t critical value?
7 minus 1.
You could. I wouldn't. Does anyone know what degrees of freedom I'm going to use?
466.
Remember, the calculator gives me one, doesn't it?
Oops.
Probably.
So what are we going to do? Okay. So you can do 7 minus 1. It's the more conservative approach. So remember, the calculator is going to spit out a degrees of freedom for you. How am I going to use that degrees of freedom to find my critical value?
Menu.
So menu, 5 distributions, inverse t. What's the area?
98 point some. Or point.
Remember, 98's in the middle.
Oh, 0.99.
So either 0.99 or 0.01. Draw it out if you need to. I believe it was 11.8566. Here's my critical. So again, if you're stuck and you don't know how to find that critical value on the free response, can you just put the statistic the calculator gives you plus or minus the margin of error the calculator gives you? Yes. Do something more than nothing. I'm willing to bet they would give you credit. They do want to see this all the way written out, but if you're like, I don't know what t star is, I'm not sure how to get it, then skip that part. Put the margin of error and move on. Okay? Like write out the specific formula, but don't split that. Alright, so from there, what's my confidence interval? So based on this confidence interval here, does this provide convincing evidence that the new medicine is better? Why not? Because what?
Wait, say that again?
Does this interval provide convincing evidence that new is better?
No, because 0 is in the interval.
0 is included, so 0 is
Plausible.
plausible. Yeah, so is there plausible that there's no difference?
Yes.
Yeah. So this does not provide convincing evidence that the new is better. Does that correspond to what we had when we ran through the test?
Yeah.
Yeah. That p-value was greater than our alpha of 0.01. Right? So remember, the confidence intervals, the hypothesis test, they tell the same story. The reason why we stress so much about hypothesis tests, though, even though confidence intervals give more information, is some statistics out there you can't do an interval with. You have to do a hypothesis test. Okay, so there's that. Same exact thing. Now, that was when we had 2 different samples and we did a 2-sample test. Remember, we did this a second time, though, where we did a what kind of design? Matched pairs design, where we paired our data up, right? So I made this note over here for yesterday, I don't know if y'all saw it, but when you have a paired t-test, when the individuals are paired together from the beginning, and you take a difference of the pairs first. But once you take a difference of the pairs, does that look like a 1 sample or a 2 sample? 1 sample. You know how the test runs? Exactly like a 1 sample. The confidence interval runs just like a 1 sample. And so remember, we did this test, and when we did this test, did we get convincing evidence that the new was greater than the old?
I mean, no? Yes. Oh,
Did you
yes.
look at the calculator? That's what's up there? Did we get convincing
Sorry,
evidence
sorry,
that the
I
new
was-
was better?
I flipped the thing in my brain.
Gotcha. Yes, that's a wicked low p-value, right? That's so unlikely by chance alone. So if you look like you had a question. Is that p-value lower than alpha or higher than alpha?
Lower.
So we would reject our null hypothesis. That is statistically convincing evidence. Notice my t is 10.5. That's a really high test statistic. And look at it, almost this entire distribution is above 0. Okay? So, what I need us to recognize out of this is 2 things. The benefit of pairing is we reduce variability. What was it that we paired on? How did we pair our data together? Do y'all remember? Well, we did a matched pairs design, but we could have looked at initial cholesterol or weight, or I think age was an option as well, right? The initial cholesterol provided the highest correlation. So like if we did a 5-area set of data, it actually had a correlation of 0.99, whereas I think weight had a correlation of like 0.65 to making all this work. So this was definitely the best one. So when we can pair our data together, what's that going to be able to do? Reduce our variability. One of the groups is looking at teachers and sleep on the weekend versus the weekday, right? And I want y'all to think about this. If they collect data from the same teachers on their sleep for the weekend and versus the weekday, do we want to just look at all of the hours or find the mean? Yeah, find the mean of the weekends and subtract the mean of the weekdays, or do we want to pair that data together? I would say, if you have data from me 2 different ways, is there going to be someone more similar to me than me?
No.
No. Could my sleep on the weekends be more similar to my sleep on the weekdays? Yeah, 100%, right? And so a paired set of data, in this case, would be very beneficial. So what you're going to do is, you're going to take, say, my weekday sleep, subtract my weekend sleep, and then you get one paired set of data. So guys, if you can pair that data together first, subtract first, and then do a mean, that's a matched pairs. That accounts for the variability from me to Ethan to Miss Williams to Leah to whatever, right? So it accounts for that variability due to the person themselves. So So pair your data together if at all possible. Yes, Madeline?
When you do like a null hypothesis with matched pairs, do you do it differently? Since you're subtracting.
So the null, yeah, so I'm about to look at that with this, but the null for a matched pairs would be mu sub d. So the mean of the difference. So notice, so you have the mean of the difference versus a difference of the means. But the mean of the difference is 0 versus the mean of the difference is not 0 or is greater than 0 or something like that. So that's the only difference.
Remember when we were in the vertical surfaces and I asked if it's the same for like v1 minus v2 and then I wrote v1 minus 2? Is this where you're doing right there? Like all in subscript?
So mu x bar 1 minus x bar 2 is mu 1 minus mu 2 from the idea of combining random variables. But you wouldn't just say mu 1 minus 2 would be x bar 1 minus x bar 2. But here it's going to be the sample mean of the differences. Because remember, the mean of the statistic is the parameter from our sampling distributions unit. But just leave it like this. Don't sweat that detail. But it's going to be the mean of the differences. Yes, start.
So for our project, would you want us to write it like that, or would I don't know.
Well, if you can do a paired set of data is going to make it easier to find statistical significance. A paired set of data will allow it to be easier to find paired, so like, oh yeah, because y'all are doing the jumping one, right? So like realistically, what you could do is you could have a person one day, and you might need to randomize if they do no stretching first or stretching first, but have them not stretch one day and then stretch another day. But because y'all are doing multiple intervals, I probably wouldn't do that. Because you're doing like 1 minute, 2 minutes, 3 minutes. So you would have to collect data for each person at each of those interval values.
Also, I feel like like 8 minutes, it's a lot of time for somebody to just stretch.
Yeah.
I promise you this, 5 to 8 minutes is a minimum of how much we, I would say 8 minutes, about how much I stretch every morning when we do CrossFit.
But like, I'm thinking like,
To do a single jump, it's your choice.
but still, would you rather intervals of 1 minute or 30 seconds?
Your choice.
Right.
I would say it is 0.5 minutes instead of 30 seconds, just to make it cleaner, or convert it all to seconds. Alright, but let's get to, please and then last thing is this. So, if I was doing this matched pairs with paired data like this, and I wanted to do an interval, what type of interval would I be doing here?
T interval?
Okay, so confidence intervals. So am I going to do a t interval or a 2 sample t interval?
T interval?
So I've gotten it down to 1 sample essentially, haven't I? So I'm going to run the differences as a t interval, or run it exactly the same as a 1 sample interval. Difference. What did I say the confidence level is? 0.98?
Right.
Notice in this confidence interval, do we have convincing evidence that the new treatment is better?
Yeah.
How do we have convincing evidence that the new treatment is better in this one?
0 isn't in there.
So 0 is not in the interval. 0 is not what? Plausible, which means the new, yeah, all the plausible values are over 0. So please understand big things here. Hypothesis testing, confidence intervals, whether it's proportions or means, they're the same.